each neighborhood separately. Okay. The second one is we pool all the data together and estimate the water quality of the city as a single group. Because now we understand the group, right? Okay, but a lot of this is just one example, but a lot of time, okay, the problem has a hierarchical nature, okay. So this is one example, obviously. For example, like if I consider student performance, okay, because like in our department, like for undergraduate student performance, like in our department we have 2 classes, right? For each year we have 2 classes, and so we can also consider, okay, the performance of student in each classes, or we can consider the student performance as a whole, right? So a lot of problem has this hierarchical architecture. Or let me use another example, okay? If you like baseball, right? I mean in Taiwan, because we just lost the game. Yeah, probably not a good idea to use this example. Okay, NBA, for example, NBA, because NBA is still like very hot recently, right? Because it's close to the final moment to decide like which team will get into like playoff, right? So like if you want to consider NBA team, okay, for example, in a particular position, for example, like because everybody like Jeremy Lin, right? So let's use the point guard as an example, okay? Because every team has point guard, right? Okay, so when you consider point guards, okay, well, you can, because you have different teams, right? Different team has point guard, but of course, if you consider just point guard in one team, that's probably not too many, right? Only 1 or 2 players, okay, in one team. But if you consider, for example, point guard like in respective division, okay, NBA is divided into divisions, right? So different division, okay, has a lot of point guards, right? And again, different division, combine form the NBA as a whole, right? So again, you can see there's such a hierarchy, okay, very naturally built in this problem. Okay, a lot of problem has this hierarchical nature. Okay, so it is very common to consider hierarchical models. Okay, so let's continue with this example. This is just one example, and you may be able to see many similar hierarchical example. Okay, so both options. Okay, this study each neighborhood separately, or pool all data together and estimate the water quality, of the whole city. Okay, so both options has the pros and cons. Okay, because the first option allows you to see the differences between different neighborhoods, right? Because you are analyzing the water quality of different neighborhoods. So now you are able to estimate like water quality. And be able to identify, okay, which neighborhood has a better water quality, which neighborhood has a inferior water quality, right? Remember like the group comparison technique that we just discussed, right? So we can do that, right? But okay, on the other hand, okay, because each neighborhood you may only collect a few number of samples, right? So number of samples will be small for each neighborhood, right? Okay, but if you pool all the data together to estimate the water quality of the whole city, you have a larger amount of data set, which allows you to estimate, like do this analysis in a much more much more confidence. Like for example, like it's just like remember coin flip. If you just collect 4 flips, okay, and another case if you collect 40 flips, even with the same ratio of like a head and tail, one is like this, another one is like this, right? Okay, same thing here. Okay, with more data, it will tell you a much stronger story. Okay, so both options has its pros and cons. Okay, so both are good reasons, but we can do something else. Okay, if you take this one, the first one and second one, okay, so you lost something in between. Either you take first one, I mean you lost some advantage. You take the second one, you lost some other advantage. So what we can do is we can do something else, something in between. We can build a model to estimate the water quality of each neighborhood and at the same time, okay, estimate the quality of the whole city. So this can be done simultaneously. Okay, that's the beauty of the hierarchical model. Actually, like as I said, like most of the questions fall into this category because a lot of questions has this hierarchical nature. Okay, so this type of model is known as hierarchical model or multi-level model. Okay, in terms of the model, it's really not that difficult. Okay, because we model the data using hierarchical structure or one with multiple levels. So, I mean, previously, for example, let me just use any example that we had previously. You see that it's already kind of like a multi-layers, right? Right? We already have 2 layers. So far, the examples we use, I mean, the model has 2 layers, right? It's always like that, right? We could, like, increase this level. That's not a problem. Okay, instead of fixing the parameters of our prior to some constant numbers, we estimate these parameters directly from the data by placing shared prior over them. So this higher level prior is called like a hyper priors or like a hyperparameters. Okay, they are parameters, hyperparameters. So hyper just means like over. I mean, well, it's just, of course, this is also possible to put priors over the hyper prior. So create as many levels as you like. Okay, so here, okay, we just tell you, okay, we can have not only 2 levels, we can have 3 levels, we can have 4 levels, we can have many levels, as many levels as you want, because each level represents like a layer in your problem. Like for example, like water. Okay, this water quality case. Okay, one level can be used to represent like a neighborhood. Another level can be used to represent like a city. Okay, so something like that. So unless the problem really demands more structure, okay, I just told you we can have like as many levels as we want. But at the same time, don't use too many levels because each level you introduce, okay, it's going to complicate the problem or complicate the model, okay? And after you analyze, you have the result, okay? You need to be able to explain the result, okay? And if you introduce too many levels, sometimes it will be very difficult for explanation, okay? So you should just put enough level, or just enough level, okay? you don't just arbitrarily introduce, the number of labels as you want. Okay, you just put enough number of labels. So after all, the main idea of building models is to make sense of the data. Okay, so thus models should reflect the structure of the data. Okay, because in the hierarchical nature type of problem, okay, the data you collect actually, has a hidden hierarchy inside that. So your model should also have a hierarchy to reflect that. Okay, but not too many labels. Okay, just enough. Okay, so well, I think we are running out of time. So this water quality example, let's talk about this next time. Okay, this is hierarchical model is very, very important, as I said. Okay, which once we finish this hierarchical model, we'll be able to talk about, like, for example, the generalized linear model, okay, which is a norm, okay, for analyzing like a lot of real world problems. Okay, so let's take let's stop here. Okay, we will continue. I think we will be able to finish this chapter next time. Okay, because yeah, we have only like 20 slides. So after we finish this slide, we will move on to talk about MCMC. Okay, I think the slide has already been uploaded to E-class. So please remember to check it out, okay, next time, okay? So I'll see you next week, okay? Okay, thank you.
我想问一下有一个weekend tips problem，就是你的 filter 跟